Hi students, welcome to your math lesson on what is today? Tell me what today is. Today is Monday, the beginning of the work week. And to write our date in number form, we need three things, and what are they? Shout them out. We need the month, day, and year. So if you hold up your fingers and count with me until we hit the month of November, let's figure out how many fingers we have. January, February, March, April, May, June, July, August, September, October, and November. I got 11 fingers, so 11th equals November. So remember, you can put slashes or you can put dashes. And then we need the day of November. So on Friday was the 6th, right? So we count on Saturday's the 7th, and the 8th is on Sunday. Today has to be the 9th. So today is the 9th of November. So the 9th. And remember, there's 30 days in November, not 31. And then the year is 2020. Some people put the full year or some people put the last two digits. So those are some ways you can write the date. Let me fix my little dash right here. There we go. Yay, and we figured out today is Monday, 11/9/2020. Last time we counted to 120 in our lesson. So before we, count all the way to, we're going to count to 130 today. So what I'm thinking is I'm going to count to 0 to 100 on my screen, and then I'm going to erase the 100 and start counting from 100. Okay? So let's begin with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh. Yeah, we're going to pause on 10 and then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There we go, there's my 5. 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and 60. 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. Whoop. Oh. We were on 73. Now we're on 74, 75, 76, 77, 78, 79. And what do you think comes next? 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. What's next? 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, and we're going to take a pause here. What do you think? What comes next after 99? Shout it out loud. Nice and loud. 100. So I'm going to clear this page. We counted from 0 to 99 on this page, and now we're going to start fresh on 100. And we're going to count to 130. 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 100, oop, yeah, that was a bad, yeah, let me redo that one. Yeah, since we're on pause, 113, what's next? 114, 115, 116, 117, 118, 119, and 120. 121, 122, 123, 100 and, ooh, you know what I missed? I missed the 100. There we go. 124, 125, 126, 127, 128, 129, and 130. We did it. We counted to 130. That's pretty impressive. Smiley face. Oh, we did it. We are math geniuses. Okay, awesome. Now, if you want to go to your 3.3 Big Ideas book, that's where we are on. Some of you, this is new information, and some of you, this is kind of a review for you, but review is not going to hurt you. It's just going to make you better in math. So we're still on the part-whole model. So I'm going to draw this part. And what is this part called? These are the two parts. These two boxes symbolize the two parts. They represent the two parts. And then you see a line at the bottom, and that represents your whole. So the whole represents both of your parts together. So that's why part plus part equals whole. So you know this part at the bottom equals the amount what's up here. So if you think this number plus this number equals what's down here. So I'm going to erase this part. But that's how I like to think of it, because it makes it easier, right? Because if you think about it this way, would you put 3 plus 7 equals 4? No, you will put 3 plus 4 equals 7, because part plus part equals whole. So let me erase that guy. Bye-bye. Okay, so your Big Ideas books, you'll see like you're either missing an add-in, you're missing like, you know, something that you subtract with, or you're missing your answer. So for example, so we're still kind of playing with the dots. So you might see like 2 dots in your Big Ideas book. And you might see 4. So something like this. And then you see something that might look like X or question mark minus 2 equals 4. So what is X in this problem? What do you think X represents? So we're trying to figure out what X is minus 2 equals 4. So we're trying to figure out what answer equals 4. We can try to solve this problem by using our good old pal, the number line. So let's try to figure out the X is in this problem. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to pause at 8 for now. So this answer, X, has to be the bigger number, right? Because we're trying to figure out what Because like when you have your answer, we landed on here, right? So we're minusing 2. So we know x is going to be bigger than 4, right? Because we're using a minus sign in this problem, and minus means to take away. So we can even work backwards and do counting upwards till 2. So 1, 2. So I landed on number 6. So if we erase the x, 6 minus 2 equals 4. Do you think that's right? We can count backwards. So if we were going to do this problem in reverse, 6, right? We can count backwards since we're not taking away some. So we can go backwards 1, 2, and also lands on 4. But if we were trying to think of this problem, part plus part equals the whole, right? So let's count how many dots we have to see if these equations match up right. So how many dots do we have up here? We have 1, 2. We have 2. And then we have 1, 2, 3, 4. We have 4. So 2 plus 4 equals what? So we can also use the number line. So I'm going to minus this just to erase this just to show you guys. So we can start on 4, for example, because that's one of our add-ins. So if we land on 4, how many more do we have to go up? And since we're adding more, that means we're moving further away from 0 because we're doing add. We're going further away from 0, so we're going to add 2 more away. 1, 2. And look, we both landed on 6. So 2 plus 4 equals 6. So 6 is our whole, and then 2 and 4 are our parts. So 6 minus 2 equals 4 is correct, because you can tell both of those problems have the same numbers and everything lines up correctly. So we did that problem correct. Let's try another example. So we have our parts, and then we have our whole at the bottom. I'm going to leave like a little blank in the middle so I can put my whatever the whole is in the middle. And we have our, I'm going to do green. We have 1, 2 dots. So what does that mean? What does that tell you? We have 1 dot in one part and 1 dot in another. And then we have x or question mark minus 1 equals 1. So if we want to work backwards, so if we just want to rely on our model right here, we know 1, so we know this is 1, and then we have 1, and then we have this is 1. So remember, part plus part equals whole. So if we want to go on the side, 1 plus 1 equals what? So if we just want to count our dots together and not use the number line, we have 1, 2. That means our whole is 2, right? So our whole is going to be right here, 2. So in this problem, remember what I said, that this number right here is probably going to be bigger, right? Because we're minusing some to equal something less. So in this problem, x is going to be 2. 2 minus 1 equals 1. So for example, we have 2 at the top right here. We have 2 at the top. That's the total, right? But if I was to take away 1, then what do we have left? We have 1. So this shows that we did this problem correctly. Okay. So it's really cool. You can figure out this problem in multiple ways. Like I said, a bunch of times. You could do number counting. You can do the number line. Math is really cool because you get one answer, but you can do multiple ways to solve that answer and multiple ways to check your answer too if you want to try a new way in math. As you can tell, Ms. Schultz loves math. That's my favorite subject. Now, let's try a different example. And I promise this is your last one, and then I'm going to let you guys practice on Class Dojo. So, we're going to pretend we have 1, 2, 3, 4. Let's see, I'm going to put my dots, and then we have the whole as 8. So, if I was to ask you to write this in an equation, it could be addition, it could be subtraction. What do you think you would do? What do you think you would write down? So let's first try it as an addition equation problem. So remember, part plus part equals whole, so this should be pretty easy to write it as an addition equation problem. So if we were to count out how many parts are in the first box, we have 1, 2. we have 2. Since we know this is one of the parts, this is going to be our add-in. 2 is going to be our add-in. So 2 plus the other part, which is 1, 2, 3, 4, 5, 6. 2 plus 6 equals, and then we have our whole down here, so we know it's 8, but if we want to double check, we can always count the total dots together just to make sure. 1, 2, 3, 4, 5, 6, 7, 8. And that's correct. We know we did this one right. Now, what if I was ask you if I was to write an subtraction equation problem? We know we're going to always put our bigger number in front of the subtraction equation problem first. So in this case, 8 is the greatest one, right? So we're going to write 8 first. Minus, minus. What if I was to say 2 were taken away? How many's left? So I'm going to say 2. And if we count right here, 1, 2, 3, 4, 5, 6, we have 6. And what if I say 6 was taken away? Bye-bye, 6. 8 minus 6. And how many's left? 1, 2. We have 2. So those are three different ways you can write a addition equation and subtraction equation problems, because part plus part equals whole, but if you take away one of the parts, you're going to get different answers to the part. Because you see, if we took away 6, or if we took away 6, we get 2, and if we took away 2, we get 6, because we have that clue from up here. Okay, awesome. So I'm going to assign some worksheets on Class Dojo so you guys can practice and have fun with it, because the more practice you have with these kind of math problems, they're fun. It's kind of like solving a puzzle, to be honest. But I hope you guys enjoy this lesson, and if you're confused about anything, just reach out to me and make an appointment with me during my office hours, and I'm happy to go over this information with you. And yeah, I'll see you guys next time.